It's okay. It's okay. So for our fourth rule tonight, you guys already have rules 1, 2, and 3. First of all, we always have to do the same thing on both sides of the equation. So if I perform an operation on one side, I have to keep my equation balanced by doing it on the other side. Secondly, we undo the steps of a problem by doing the order of operations in reverse. And thirdly, we saw the exception to that rule today, where if we have an entire side being multiplied or divided, we cancel that out first before we do anything else. So rule number 4 for you guys is we have to combine like terms before we can solve for a variable. So before we could do anything else, we have to combine like terms. And that sounds great, but what are like terms? First of all, let's just talk about what terms are in general in math. So if I have a term, it could be a number by itself. It could be a variable. Or it can be a combination of a number with a variable. So some examples are 5. 5 could be a term by itself. The letter X could be a term all by itself. Or I could have something like 5x that is a term all its own. If I'm given an equation, like what we've been seeing, so let's say I had something like 5x plus 3 equals 8. Terms are separated by addition, plus signs, or by subtraction. So this would be a term, and this is a term. Let's write that down. Terms are separated by plus or minus signs. So never multiplication or division, because we already set up here, it could be a number with a variable. So something like this, which represents multiplication, is a term all its own. We only see different terms when there's that separation, either addition or subtraction. And also, on this side, we would have one term, the number 8 by itself. Okay, so in total, in this problem, I have 1, 2, 3 separate terms. So if we go back to our rule number 4, combining like terms, let's move back over here. Combining like terms, we need to know what like terms are. I've learned about terms, I've learned that I have to combine them, but which ones are considered like each other? Okay. So like terms are terms that have the same variable which is going to be raised to the same power, like terms are also numbers by themselves. So we just saw with our terms how we could have a number by itself. And the fancy name for those numbers by themselves is a constant. So anytime you're using regular old counting numbers, that's just a constant in an equation. So if I go back to what I already did, here is a term that has a variable in it. So this is one term. And this would be a constant term because it's a number all by itself. And even on this side, we can consider this a constant term. For our practice, we're not even going to be working with equations, so we're going to take the equal sign out of it altogether. We're only going to work with expressions, which is a math sentence that doesn't have that equal sign or an answer after it. Okay? So follow this example with me. Tonight, your summary is just to make sure you have this information with the rules and that you are also doing these couple examples with me, and then I'll give you a few to do at the end for questions. Okay? So I'm going to give you a math sentence that has a lot of information in it. Let's say I have 5x, not sure why I'm stuck on the 5x today, plus 7 plus 2x plus 3. And I made it easy at first. We're only dealing with addition here. I need to find and identify my like terms. I put different shapes around my like terms. So in this case, I see that I have two terms that both have an x in them. That is the same variable. They're only raised to the first power. So same variable to the same power, I can combine them. And as I put boxes around them, I always include the operation symbol in front of it so I know how I'm combining them. 7 and 3 don't have an x, so they are not like these two. 7 and 3 are numbers on their own, which we call what? Constants. So 7 and 3 are like each other. So I might use a different symbol to show that those are like each other. So now I can combine the ones that are like terms. 5x, oops, and I didn't include my circle around my plus, which I told you to do. Okay? Let's go back and do that. So we know whether we're dealing with positives, negatives, adding, subtracting. We can see it's all addition here. So I have 5x plus 2x. That gives me 7x. And then I have 7 plus 3, which is adding a positive 10 to it. This is as far as I can go because this term has an x in it. This term is a constant. They're not like each other, so I can't do any more at this point. Let's try another example. You guys try this one without me. Let's say I have, actually I'll do this one with you because I'm going to change it up a little bit. Let's say I have 4m plus 2 plus 3n minus 2m. So let's go through again. This term here has an m in it, so that's a term by itself. Do any of the other terms have m's in them? Yes, this one does. I have a minus sign in front of it. Now this term has a variable, but it's not like the m terms, so this cannot have a box around it because it's not the same variable. So I'm going to give this one a different symbol. And then I have a constant by itself here. So I'll just put a triangle around that, I suppose. So I can combine the things that are like each other now. Both my boxes are m terms. 4m minus 2m is 2m. I have a plus 2, and then I have a plus 3n. I try to keep all my variable terms first and put my constants at the end. So I'm actually going to bring down my plus 3n first. And then lastly, I'll bring down my constant, my plus 2. Again, at this point, I don't have any terms that are like each other, either being constants on their own or the same variable. So this would be my final answer. I'm done. Okay. I'm going to have you try one tonight where you are combining on your own. So let's do, actually I'll have you try a couple. Let's do 3 of them. 1, 2, 3. And tomorrow when you come in, be ready because we're going to be combining like terms and then solving for the variable based on that. So for number 1, let's go with x's again. So I'll do 7x plus 6 minus 4x minus 3. This should go under your Q, your questions. Second one, let's do, I will use the variable p. So let's say I have 11 plus 3p plus 14 plus, I don't know, what do we want to do here? 6p. And then lastly, number 3, we'll use the variable y. So let's say I have negative 2y plus 7y minus 4. Let's make that plus 4 because that's going to confuse you. And then plus another y. So be careful with this one. We have a negative and we also have a few that are the same. Okay? Keep that in mind. Bring these in tomorrow. Make sure you have that rule written down. We learned about terms, like terms today, and we're going to be using that tomorrow in class. Have a good night.